All right, today we're talking about the slope of a line. So the slope is sometimes described as rise over run. It's the change in y over the change in x. So if you have 2 points on the line, x1, y1, and x2, y2, so if those are 2 points on the line, then your formula to calculate the slope, m represents the slope, so we say m equals y2 minus y1 over x2 minus x1. Okay. All right. If the line is going up from left to right, that's a positive slope. If it's going down from left to right, that's a negative slope. So this would be a positive slope. That would be a negative slope. If it's vertical, then that's an undefined slope, and horizontal would be a slope of 0. All right. So the slope-intercept form of the equation of a line is y equals mx plus b. So m is the slope and b is the y-intercept. So if we're looking at a graph, and we want to find the slope of the line, first of all, for number 1, the slope is going to be negative. For number 2, the slope is going to be positive. We can tell just by looking at it. So we could write down the coordinates of those points and then use the formula. But if you're looking at a graph, you can I would just count them. So as you're going from left to right, so you're going 1, 2, 3, 4, 5. So that's down 5. That's negative 5. And then you're going over how many? So 1, 2, 3, 4, 5, 6, 7, 8. You're going over 8. Down 5, over 8. That's your slope. Number 2, okay, it's rise over run, so count how many you have to go up. So you have 1, 2, 3, 4, 5, 6, so that's up 6. And then over 1, 2, 3, 4, so up 6 over 4, and we could reduce that to 3 over 2. Okay, number 3 is asking what is the grade of the hill, so the slope. So rise over run, so that would be 32 over 108. And then reduce that. So I think we could reduce that by 4, because 4 goes into 32 8 times. And 4 would go into 108 27 times. Yeah. So 8/27. Oopsie. Okay, number 4. What is the pitch of the roof, which is another way of asking the slope. So again, rise over run, so that would be 6/20. And then reduce it. That's 3/10. All right, decide whether the slope is positive, negative, or 0. And same thing for the y-intercept. So not really doing any calculations, but just looking at it. So we can see for number 5, is the slope positive, negative, or 0? Negative. It's going down. And the y-intercept is negative because it's below the x-axis. And for number 6, the slope is 0. It's horizontal. And the y-intercept is positive because it's above the x-axis. All right, number 7 says, find the slope of the line passing through the pair of points. All right, so I start by labeling my x1, y1, x2, y2. So like x1 is 4, y1 is -1, x2 is -2, and y2 is -8. And then I'm going to plug those into the slope formula. And just be careful about negative signs because you've got some of your numbers are negative, and as well as you have the subtraction in the formula. So it's y2 minus y1. So that's -8 minus -1. So a lot of people will mess up and just write like -8 minus 1. But it's important that you have -8 minus -1 because that's going to turn to a plus. And then on the bottom, you're going to have -2 minus 4. So like I said, that turns to a plus. So -8 plus 1 is -7. And then on the bottom, -2 minus 4 will be -6. And those negatives just cancel each other out. And so it just turns out to be positive 7/6. Okay, find the slope of the line. So y equals 2x minus 3. So that's your slope-intercept form. So if you just compare that to y equals mx plus b, then you can see that m is 2. And they didn't ask you about the y-intercept, but you can really quickly figure that out as well, because b is -3. For number 9, it's not in slope-intercept form, so that's what I would do first, is to put it into slope-intercept form first. So the first thing to do for that is add 3x to both sides of the equation. That would make it -4y equals 3x plus 2. And then we have to divide everything by -4. So just divide each term by -4. So that makes it y equals -3/4 x minus 1/2. And then we can see that m is equal to -3/4. And for number 10, y equals 4 is a horizontal line. There's no x there. So the slope is equal to 0. And then number 11, x equals so x minus 5 equals 0. So there is no y there. So that automatically tells me that it has to be a vertical line. So like, I guess I don't have to do this part, but I will just make it x equals 5. So that's a vertical line. Which means the slope is undefined. Okay, number 12. Graph the linear function using slope and y-intercept. All right, so we can see that the slope is equal to 1/4 and the y-intercept is equal to 1. Okay, so whenever I graph the line, I like to just plot my y-intercept first. Okay, so there's that. And now my slope is 1/4, which means I'm going to go from that point that I just plotted, I'm going to go up 1 and over 4. Okay. Number 13, graph the linear function using slope and y-intercept. All right, so we can see that m is -2. That's the slope, and then the y-intercept, b, is 5. So I'll go ahead and plot the y-intercept first. And then the slope is -2, which is the same thing as -2/1. So from the point that I already plotted, I just need to go down 2 and over 1. And I can, technically you only need 2 points, but since I'm doing this by hand, just to make it easier on myself, I would probably just keep on going down 2 over 1 and drawing more points. So that helps you draw a better line. All right. Graph the linear function using slope and y-intercept. So in that case, the equation is not in slope-intercept form right now. So I need to, that's what I'm going to do is get it in slope-intercept form. I'm just going to rewrite it right here. Okay, so I'm going to subtract 7x from both sides. So that gives me 2y equals negative 7x. And then just divide everything by 2. So y equals negative 7 over 2x. So my slope, m, equals negative 7 over 2. And my y-intercept, b, equals what? 0. All right. So I'll plot the y-intercept. And then my slope is negative 7 over 2. And this graph is not really big enough, but oh well, we just do what we gotta do. Almost, it just goes slightly off. All right. Okay, let's see. Next. All right. Equations of lines. Okay, so equations of lines can be expressed in different forms. You have standard form, which is ax plus by equals c. I don't like that one. And then you have the slope-intercept form. So we basically talked about all these a little bit already. So vertical line would be x equals a number, horizontal line is y equals a number. And then you've got the slope-intercept form, which is y equals mx plus b. Yada, yada, yada. We talked about that. Okay. Point slope form. So we haven't talked about that yet. Point slope form. Or I like to call it the point slope formula. Point slope form, same thing, I guess. So if you know a point that's on the line and you know the slope of the line, you can plug them into that formula to get your equation of the line. So when you're using that formula, you're just going to plug in a number. You're going to plug in your point. That's going to be your x1 and your y1, and you're going to plug in the slope for m. But you're not going to plug anything in for the plane y and the plane x, because that's still going to be part of your like answer when you get this equation of the line. So write an equation for the line described, give your answer in standard or slope-intercept form. I always do slope-intercept form, so I don't like standard form. Because slope-intercept form, you can easily graph it based on that. Standard form, you can't. So, all right. Okay, that's like my bones of my formula, and then I'm going to plug the numbers into that. So x1 is -5, and y1 is 4. Okay, so y minus y1, so that's y minus 4 equals m, which in this case is -3/2, times x minus -5. Okay, from there we just need to simplify it so that it gets into slope-intercept form. So minus a negative is a plus. Okay, so I have y minus 4 equals -3/2 times x plus 5. And next I'm going to distribute 3/2, or -3/2 rather. So I still have y minus 4 equals, and then I have -3/2 x minus 15/2. And then I just need to add 4. All right, so I have to do -15/2 plus 4. So I'll just use the bow tie method, which would make it -15 plus 8 all over 2, which equals -7/2. So my final answer is y equals -3/2 x minus 7/2. Okay. Number 2 says a vertical line passing through the point 6, -4. So it's a vertical line, it has to be x equals a number. And that number would have to be 6. That's the x value of that point. Number 3, a line with 0 slope and a y-intercept of -2. So if it has 0 slope, that means it's a horizontal line. And if it has a y-intercept of -2, it has to be y equals -2. And I should close that door. All right. It says, write an equation for a line passing through 410 and 612. So first, we're going to have to use the slope formula to calculate the slope. So that's the x1, y1, x2, y2. So m equals, that'd be 12 minus 10 over 6 minus 4. So that equals 2/2, which equals 1. So your slope is 1. So y minus 10 equals 1 times x minus 4. Okay, so y minus 10 equals x minus 4. And let's just add 10 to both sides. That's going to give us y equals x plus 6. Okay, and then number 5 says use the order pairs 0, 32, and 2576 to find the equation of the line that approximates the data. So in other words, just the same thing as we just did on number 4. So we have x1, y1, x2, y2. So m equals 76 minus 32 over 25 minus 0. So that would be 44 over 25. Okay. So that's the slope. Okay. All right, so y minus 32 equals 44 over 25 times x minus 0. So that's y minus 32 equals 44 over 25x. And then just add 32 to both sides. So y equals 44 over 25x plus 32. All right, number 6 says the graph of a linear function is shown. Identify the slope, y-intercept, and x-intercept. Then write the equation that defines the function. All right. Okay. So the y-intercept is right there at -3. That's b equals -3. And I can see the x-intercept looks like 4. And I can count out the slope. So the slope, I have to going from left to right, so I have to go up 3 and over 4. So the slope would be 3/4. All right. So the x, so I already wrote down that's the y-intercept and the slope. That's all I really need for the equation. Oops. So the x-intercept is 4, 0. And then the equation of the line will be y equals 3/4 x minus 3. All right, number 7 says it costs $2,000 to purchase a copier, and each copy costs 2 cents to make. So what is the fixed cost and what is the variable cost? That's right. So fixed cost is 2,000. Variable cost is 2 cents per copy. So the cost equation, C equals 0.02x plus 2,000. What would the cost be to produce 10,000 copies based on the cost equation? So just plug 10,000 in place of the x there. 0.02 multiplied by 10,000 plus 2,000. Okay, so that's going to be 200 plus 2,000. So 2,200. Graphing linear inequalities. All right, so this is going to be just like graphing an equation, except just like a little bit extra on top of that. So with the inequality symbol, so if it's using a strict inequality symbol, meaning it's not or equal to, so it's just strictly greater than or strictly less than, in that case, you're going to use a dashed line when you graph it. And then otherwise, if it does have the or equal to part, then that means you're going to use a solid line when you graph it. Then after you draw the line, you're going to shade one side or the other of the line, either above or below. So if it's a greater than, you're going to shade above the line. If it's a less than, you're going to shade below the line. So think of that line as like, you know, a ladder or a staircase or something. You're either on it or you're under it, okay? So for number 1, I can see that the y-intercept is +1. So I'll plot that. And then the slope is -3. So from that point, I want to go down 3 and over 1. All right, and then I can draw the line. And this is going to be a solid line. And then we need to do the shading. So it says y is greater than or equal to, which means I'm going to shade above this line. So as if you're on that ladder. Okay, there we go. All right, number 2. So what is the y-intercept? That would be -3. And then the slope is 1/2. So we go up 1 and over 2 from there. And I'll do it a few times. Okay, and this is ultimately going to be a dashed line because it just says y is less than, not less than or equal to. It's going to be a dashed line. And y is less than, which means I'm going to shade below that line. So if you ever don't know which side to shade, there's also another way that you can figure it out, a more mathematical way. Like if you look on your examples on MyLabs Plus, it'll probably tell you to do it this way, which is, so basically it says pick any point on the graph as long as it's not actually a point on that boundary line. So like if I can pick 0, 0, I would usually pick 0, 0 because that's the easiest point to pick. And then what you do is you plug in 0, 0 into the inequality and you see if it's true or false. So like you got 0, 0 there. So I could plug that in. If I did that, it would be 0 is less than 1/2 times 0 minus 3. So if I simplify that, it says 0 is less than -3, which is false. So because that's false, that means don't shade this region that has this point in it. So that's just another way to check which side you're supposed to be shading it on. Okay, so number 3 is not in slope-intercept form. So I'm going to start by getting it in slope-intercept form, which means I'm going to subtract 3x from both sides. So 2y is less than or equal to -3x minus 6. And then I need to divide each term by 2. So that's going to give me y is less than or equal to -3/2 x minus 3. So then I can see that my y-intercept is -3. And my slope is -3/2. So it means I have to go from that point down 3/2. All right. Now, just to let you know, we could also, in case we didn't really have enough room to go that direction, or if we just want to get another point on the other side, we can change that around. Like -3/2 is the same thing as +3/2. So that would tell me that I could also go up 3 and backwards 2, or in other words, to the left 2. All right. And this is going to be a solid line. Because it's less than or equal to. And then because of the fact that it's less than, we're going to shade below. All right. All right, number 4, again, that's not in slope-intercept form, so we need to get it in slope-intercept form. So we need to subtract 3x from both sides. So that makes it -y is greater than -3x plus 4. So -y is the same as -1y. So we need to divide each term by -1. So, and remember, when you divide by a negative, you have to flip the inequality. So now it's y is less than +3x minus 4. So our y-intercept is -4. And then our slope is 3, so we're going to go up 3/1. And I could also go down 3 into the left 1. And this is needing to be a dashed line. Okay. And it's less than, which means I shade below. Okay. Number 5 says x is greater than -3. So that is a vertical line. Vertical line at -3. And it needs to be dashed. And then x is greater than. So you can't exactly say above or below exactly, but we know that the x values that are greater than would be to the right. So we'd be shading, you know, the right side of this where the x values are greater than -3. All right. And okay. So number 6, given the graph, find the inequality. Okay, so let's identify the y-intercept. Looks like -1. So b equals -1. And then let's try to find another point on the graph that we could easily identify, like right here. And then I'm just going to count. So I have to go up 1, 2, 3, 4, and over 2. So I went up 4 over 2. is just 2. And then just put that into your slope-intercept form, or your slope-intercept form. So y equals 2x minus 1. Oh, but instead of equals, we need the inequality, correct inequality symbol. So it's shaded below, which means less than, and it's dashed, which means not or equal, not the or equal to part, so just less than. So y is less than 2x minus 1. And then same thing on number 7. Let's find the y-intercept, which again seems to be at -1. So b is -1 again. And then we'll find another point on the graph, like right there. And then we'll count. So I have to go down 2 and over 3. So m equals -2 over 3. So and the shading is above, so that's greater than, and it's a solid line, so that's greater than or equal to. So y is greater than or equal to -2/3 x minus 1. Okay. All right, so that's all for today's notes. I think we need to have a test pretty soon, like Thursday. Homework, like I told you before, you got a bunch of homework that's due tomorrow. Hopefully you did all of it. And then after you do that, keep on doing more homework after that. So, all right, see y'all tomorrow.